Welcome, ladies and gentlemen. So what I'd like to do is show you how to find the missing parts of a triangle using the law of law of cosines. Now you might look at this and say, well, this is a side-side angle or angle side-side, so I should use the law of sines. Well, you want to make sure that you draw a picture of the triangle first before you determine if you need to use the law of sines or law of cosines. So I always just kind of draw the same triangle every single time. And therefore then kind of adjust based on the information I have to make sure I know what type of actually oblique triangle I have. So when I fill in the information, if I say A here is going to be 60 degrees, and then I say B here is 20, and then C would be 30. Well, you can see in this case, I have a triangle that's in the form of side, angle, side. So when you have a triangle that you're given the information as side, angle, side, you're going to want to use the information, or you're going to want to use the law of cosines. Now, the law of cosines is basically a squared equals b squared plus c squared minus 2 times b times c times the cosine of a. And you can see that when you look at your book or look at the formulas, you can see that the law of cosines kind of changes based on what based on your angle. But the a, b, and c are all just swapped. Now, it really doesn't matter, and there's really no point in me writing down all of them. What I basically like to do is you always want to be using the law of cosines or whichever form of the law of cosines based on what angle you are given. And if you're not given any angle, which is a side, 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 I'll talk about that next. But when you're given an angle, it doesn't matter if I was given angle C or given angle B, then I would go ahead and use that formula, or I would just rewrite my triangle with different letters to represent it. So again, side, angle, side, I'm going to have to use my law of cosines. I can't use the law of sines because you see here I can't create a ratio, right? I don't have a ratio of any side length, and I don't have enough information to fill in my triangle. So I have to use the law of cosines. So to do the law of cosines, basically I'm just going to plug in the information that I have into the formula and then simplify. So in this case here, I have a, which I do not know, so I'm just going to leave that as an a squared, equals b squared, so that's going to be 20 squared plus 30 squared, minus 2 times b, which is 20, times c, which is 30, times the cosine of 60 degrees. Okay? So therefore, I have a squared equals, now 20 squared is going to be 20 times 20, which is 400, plus 30 squared is going to be 900, and then minus 2 times 20, which would be 40, times 30 is going to be 30 is going to be 1,200, and then times the cosine of 60. Now, this is where a lot of students are going to get mixed up, is using, funny enough, this is where a lot of kids get mixed up, is by using their order of operations. So you can see here, I have these two added up, and then these two are being multiplied by each other. Well, I can quickly add. I mean, I don't need a calculator here to add these two. So I have a squared equals 400 plus 900 is going to be 1,300 minus 1,200 times the cosine of 60. Now, if you know the cosine of 60 degrees, you would know that by the unit circle, the cosine of 60 degrees is actually equal to 1/2. 1/2 times 1,200 is actually going to be equal to 600. So then 1,300 minus 600 is going to equal 700. So a squared equals 700. Now, to go ahead and solve for a, I need to go ahead and take the square root. So I'll take the square root of 700. And that gives me 26.45. So I could say a equals, so I take the square root of both sides, a equals 26.4. If I round to the 100th, it'd be 26.46. All right? Now, again, remember we introduced the square root. You're doing plus or minus, but we're talking about lengths. So therefore, we only want to deal with, we can only deal with the positive length of a triangle. We can't have a negative length. Now, here's where it gets interesting. So in reality, the first part was, just plugging in information. And for this problem, I kind of just chose some values that were pretty simple. But some of them you might have to use you're going to have to use your calculator on, and just be very diligent. Just make sure you plug in the information based on the formula, square, square, multiply. Then I add these up, I multiply this together, and then I subtract them. It's a very step-by-step how I follow my order of operations. OK. So now what we need to do is we still need to figure out our angles. We haven't figured out one angle yet. So the trick is, if you remember, when we were doing the law of sines, there was that ambiguous case, right? And we didn't really like the ambiguous case. But the only way we got away from the ambiguous case is when we had something as far as an angle side angle, when we had two angles that we could deal with. Well, the problem is we don't have two angles. We can't figure out, or even if we had angle side, right? If we had angle side, we could get away from the ambiguous case. We don't have two angles. So we're dealing with something because that ambiguous case came up from side angle. So, you could do side angle, side angle. So we're kind of stuck. Well, there's a way to avoid the ambiguous case if we can. And the way to avoid the ambiguous case is we want to be able to pick the angle that is always, so if here's my two side lengths, so if here's 60 degrees, we want to be able to pick the angle that's always going to be acute. So the side length that's always going to be acute. So if you look at this, so if here's 26, you have two angles, right? So you have 30 and C. So C, or angle C is across from 30, and angle B is across from 20. And if you look at that, obviously, if you just think of like a triangle as like projection, right? If one side length is projecting onto 20 and the other one's projecting onto 30, we know that B is going to be your acute angle. So therefore, we want to be able to find the angle that is always going to be acute. So I'm going to use my law of sines to figure out angle B. Because I want to figure out the angle that I know is positively going to be acute. Okay, so to do that, I have a ratio. So I have 26.46 over the sine of A. Actually, let's do this. A over sine of A equals B over the sine of B. Okay, we know what A is, right? So A is 26.46. Angle A is 60 degrees, is equal to B over sine of B, which B is going to be equal to 20. Okay, now I can go ahead and solve for sine of B. So I can go ahead and pick sine of B is now going to be equal to 20 times the sine of 60 degrees divided by 26.46. So now I basically just go ahead and type in, wrong calculator. So I do 20 times the sine of 60 and divided by 26.46. And you can see I have 0.65. So I'm going to write out the approximation, but usually you're just going to want to keep this answer inside your calculator so you can use it next. Okay, so therefore to find B, I'm going to use inverse sine. So I'm going to do inverse sine of second answer. And that's going to give me an angle of 40 when I round to the 100th would approximate to 40.89. Okay, and again, I am approximating. So B is going to equal 40.89. Well, now since I know that was my acute angle, I have my acute angle and my other acute angle. It doesn't matter if this is acute, or it's going to be in your positive. I can simply just go ahead and subtract 60 degrees minus 40.89, and that's going to give me, 180 minus 40.89 minus 60. And that gives me an angle of 79.11. Okay? And if you're going to go and use the law of sines again, if you wanted to go ahead and check those two, you would see that it would go ahead and match out. So there you go, ladies and gentlemen. That is how you find the missing parts of a triangle when given, or using the law of cosines when given a triangle as side angle side. Thanks.